Good evening, everyone. Myself Sana Sheikh, a second year PhD student from IIT Bombay, and I'm going to take a live section of NPTEL course. Course name is Symmetry, Stereochemistry and Applications, and the course instructor is Professor Anshuman Roy Chaudhary from ISR Mohali. Today is our fourth live session. In this live session, we are going to discuss previous year assignment 4 questions, and we will discuss the concept based on those questions. So let's start the session. Before going to start the live session, I would like to give a brief introduction about RS configuration of the molecule. So what is RS configuration? So R means raster and S means sinister. Raster means right direction, turn in right direction, and sinister means turn in left direction. So R means it should be rotate clockwise direction, and S means the preference should rotate in anti-clockwise direction or counter-clockwise direction. So here you can see in this example, suppose if I'm giving a first priority, if I'm looking from this side here, so you can see here first we should know how to draw Fischer projection. This is a Fischer projection. Before RS nomenclature, we should draw it in Fischer projection. So here you can see this is the Fischer projection of this molecule. So if we are looking from this side, so A and B is on plane of paper, but B is moving towards ourselves. But C and D are away from ourselves. But C is above the plane and D is below the plane. So if we are looking from this side, A and B will be on vertical line. We have to draw vertical line, and A and B will lie on vertical line. Then on horizontal line, if we will see from this direction only here, then we will see that C is in our right side and D is on left side, because C is coming towards above the plane and D is going below the plane. So C will be written on right side and D will be on left side. The other way is also that to write the same molecule. So from other way we can imagine the molecule in this way. Suppose if we are looking molecule from this way, and you can see this image. If I am looking from this way, so the this C and D will be coming towards ourselves, but A and B is on plane of the paper, but B is away from ourselves. B is away from ourselves. So we will draw vertical line. Always you have to see the molecule in your imagination, and A and B will be on vertical line. So B is upside, A is downside. So we have to draw here B upside and A on downside. Now let's talk about C and D. So here you can see C is on right side because it's above the plane. You have to look from this side only. So C is on right side, D is on left side. So we will get this result. This is the Fischer projection. Now the third option is also there. Third way of writing the molecule. You have to look from this side. So as you can see here, A and B is on vertical line. So we have to write on vertical line A and B as written here. You can see here A and B. Now we have to write C and D on horizontal line. Then C is above the plane and D is below the plane. Right? So C is on left side and D is on right side. But what's the difference between these two molecules? These two Fischer projection, not molecule, but Fischer projection written here. These two, right? Both have different RS nomenclature. If you will see here, so if I will give priority by alphabetical order 1, 2, 3, and 4, right? So we have to check which one is correct, and then we will discuss how we can write the correct one. Okay. So here first priority is for A, then second is B, then third is C, right? and fourth one is D. So always remember this: if lowest priority group is present on horizontal line, then we have to invert the configuration. Suppose if we are getting R, then we have to convert it into S if the lowest priority group is present on horizontal line. So we have to change the stereochemistry, we can say, or configuration, not stereochemistry but configuration. So here we will see which direction it's moving. 1, 2, 3. That means it is counterclockwise direction. Counterclockwise direction. You can see here it is anti-clockwise, counterclockwise. But the lowest priority group is present on horizontal line, then it will become R. That means the configuration for this molecule is R here. Now let's check the other one here. We will check this one. So highest priority group is A, 1, then B, then C, and the last one is D, 4. Now it will move this direction 1, 2, 3. So this is a clockwise direction R. But the four, as we have discussed here, the lowest priority group is present on horizontal line, then it will become S. S, correct? Now let's talk about this one. So here 1, 2, 3 and 4, correct? And it will move in clockwise direction, again clockwise direction. That means because the lowest priority group is present on horizontal line, then it will become S, counterclockwise direction S. That means the configuration of this molecule is S. But why we are getting R here? So we will check how we can write in proper way and how to minimize these mistakes. So here you can see that if we are observing the molecule from this side, then the this A and B is going away from ourselves, right? B is going away from ourselves. You can see this is going this direction and this going in this direction. In Fischer projection, always remember that horizontal line means wedge position. Wedge means above the plane, and a vertical line is always below the plane. We have to imagine in that way. In Fischer projection, vertical line resemble back side of the plane, and horizontal line represent the front side of the plane. So if it's going below the plane A and B, and C and D is moving towards ourselves, that means this structure is correct. Because here you can see, first we will discuss about one, okay, then we will discuss about this one, okay. So here you can see A and B is on vertical line and it's moving away from ourselves, as you can see here. So it is correct way, it's written in correct way. And C and D is on wedge position because it's coming from back side to front side, that means towards ourselves. That means it is written on C horizontal line, and it's correct way. This is the correct way of representation of the molecule as configuration. When you can see here in second case, if we are looking from this side, right? If we are looking from this side, first I will erase this one. Okay. If we are looking from this side, then A and B are not uh, uh, going away from ourselves. It's not going away from ourselves, but A and B is pointing towards ourselves. You can see here B is pointing outside, not going below the plane, and C and D is going below side. But if we are writing it on vertical line, that that means it is on back side, but here it is not back side. That means this is not the correct way of writing. This is not the correct way of writing, because B is coming towards ourselves and C and D is going below the plane. But here it's this projection, Fischer projection is showing C and D is on front side and A and B is going below the plane. So this is the wrong way of writing the Fischer projection. Now in third case we are looking from this way, this side. So here you can see B is going away from the viewing position, going away from the viewing position, and C and D is coming above the plane. That means this representation is also correct, and the correct configuration of the molecule is S. S means counterclockwise. I hope all of you are clear here. I will, then we will discuss some questions based on this topic. So S and R enantiomer is here. You can see the example. Bromine has first priority, chlorine has second priority, and fluorine has third priority. If you will learn about the priority of the molecule and halogens, you will see that bromine has highest priority in halogens, among the halogens, and fluorine is the lowest priority group. Then if you will move from this side 1 2 3, then you will see this is the counterclockwise direction, and counterclockwise direction means as configuration is there, and because a proton is present back side of the plane, that means configuration will remain as it is. If proton or the uh, lowest priority group will be present on front side, that time we have to change the configuration of the molecule. So here the configuration is S, and in second case also you can find out here. First priority group is bromine, the second one is chlorine, and the third one is fluorine. So it will move in clockwise direction, and the enantiomer this is the R enantiomer. So these two are enantiomer, that means the non-superimposable mirror images of each other, and they have different uh, mo- different movement of the light, that is N inch S sinister clockwise anti-clockwise direction, and R is raster, that means clockwise direction. So now let's discuss the question here. This is the first question. So first we have to draw it in Fischer projection. So question is to draw the Fischer projection of the following molecule and determine the absolute configuration, that is R and S of the chiral carbon atom. So first we have to find out how many chiral carbon atoms are present here. So what is the definition of chiral carbon? Chiral carbon means a carbon atom which has 4 different substituents present on that carbon. That means it's a chiral carbon. So here you can see this carbon has one CH3 group, one hydroxy group, one hydrogen, that is proton, and this is the fourth group. That means it's a 4 different substituents are present on this carbon. That means it's a chiral carbon. It's a chiral carbon. Now the other chiral carbon is present is this one. These are 2 chiral carbon present in this molecule. Now let's draw the Fischer projection. So first you have to choose the longest linear carbon chain here, and you have to draw it on vertical line. You have to draw it on vertical line. So this is the longest linear carbon chain, that is a butane, 4 carbon, 4 carbon, and 2 chiral carbons are there. That means 2 horizontal line. The number of chiral carbons is equal to horizontal line present in Fischer projection. So I am writing here 2 horizontal line. Now we have to look the molecule in particular direction, from one particular direction. So here we have to choose the direction. Suppose I am looking the molecule from this direction. So this CO2H group is below the plane, going away from ourselves, right? So I will write this group here, because I am looking in that way, from that direction. Okay. Then this CH3 group is coming towards ourselves. That means it is not the below the plane but above the plane. But as I have discussed earlier, this vertical line means it always represent the back side of the plane. So what we have to do, we have to move rotate this carbon by 180 degree. This carbon carbon bond by 180 degree. Then what will happen? I will write here after rotation. Here you can see this hydroxy group stereochemistry will remain as it is, but the second hydroxy group stereochemistry will change here because we are rotating this carbon carbon bond by 180. So the front side hydroxy group will go back side of the plane, and we will get here OH, and this CH3 will become away of other side of the plane, away from ourselves if we are looking from this direction. So now it become easy to draw, right? So CH3 group will be on vertical line because it's representing the back side of the plane. Correct? Then look at this molecule. So CH3 group is upside, CO2H group is below side, downside, and now you can see hydroxy group is on back of the plane. That means front side hydrogen is present, and we are looking from that side. That means always front side position will always show the right hand side stereochemistry. So it is present on right side, OH is on left side. Now let's talk about the second hydroxy position. So it is on wedge position, that means it is on same side of hydrogen, first parallel carbons hydrogen, and hydrogen is present on left side. Okay, this is the Fischer projection of this molecule. You can draw in a different way also, like you can write here CO2H group if you are looking from this direction. So you can change the direction and draw the molecule accordingly, but you can directly interchange the substituent present on Fischer projection, like you can change these two substituent, but you have to change these two also. Okay, you can change the stereochemistry, like you can write in this way, CO2H group and then CH3 group here. Then you can imagine in that way. So here CO2H group will go back side and OH is on front side. So I'm writing directly here. You can draw by yourself also. Then it will be easy to understand. So OH is it will become on back side if we will rotate this carbon carbon by 180 degree. If we will look from this side, correct? So CO2 group is on back side, OH is right side, means it will become on left side because we are looking different way. I'm taking this CO2 group at top position and this CH3 group as at bottom position. Then that's why the stereochemistry of this chiral carbon will also change. So here you can see the stereochemistry will become this way, right? So these are two possible configuration of this molecule, and now you have to find out the RS nomenclature. So how to find out RS nomenclature? So I will write here for first carbon. So you have to write here 1 for hydroxy group because our oxygen has highest priority among the others group present on the carbon atom. So first priority will be given to hydroxy group. Then the second priority group is present this one, and the third one is methyl group. Now let's rotate the priority group direction. You will see here 1, 2, 3. That means it is a counterclockwise movement of the priority group. but counterclockwise the direction is, but here you can see least priority group is present on horizontal line. That means the stereochemistry will change here, and we will get R configuration, R configuration, because it's moving counterclockwise. Now in second case, you can see here the highest priority group present is hydroxy group, and this is the second one, and this one is third one. So 1, 2, 3, this is the clockwise direction, but again the least priority group is present on horizontal line, then the stereochemistry will change here, and it will become S, RS, RS. Now we will cross check it in this other possibility of Fischer projection. So here you can see for this first carbon, because here we have taken this carbon as the first carbon, so here first priority group is hydroxy group, the second priority group is present in this whole group, and the third one is this methyl group, right? So it will move in this direction, that is counterclockwise direction, but again the least priority group is present on horizontal line, the stereochemistry and configuration will change here, and it will become clockwise direction, that means R. And the for second carbon atom here, hydroxy group have highest priority here, then the second is acidic group, and the third one is this whole group, and it will become clockwise direction, but the least priority group hydrogen is present on horizontal line, so it will become S. So again RS is the configuration. So both the configuration, both the Fischer projection of this molecule is the uh, correct projection, and the stereochemistry is R and S. Absolute configuration of the molecule is R and S. So I hope all of you are clear in this example. Now we will solve the other example also. This is the second example. Now again we have to draw the Fischer projection first, then we will find out the absolute configuration of the molecule here. So first we have to write the longest linear chain on vertical line. So I am writing here vertical line, and two substituents present on top and bottom position are aldehyde and methyl group. So here CHO, I am writing CHO and methyl group here. There are two chiral carbon present in this molecule, so we will draw here two horizontal line. Now look at the molecule from this side. Now you will see that this carbon, this methyl group is coming towards ourselves, that means above the plane, but this vertical line means it should be on back side of the plane. That means we have to rotate this carbon bond by 180. 180. So I will write here by after rotation, the molecule after rotation. So here we have CHO group, and here CH3 group after rotation. This hydroxy will remain as it is, and because of carbon bond rotation, this hydroxy group will go back side from front side, so it will also go back side. Okay. Now here if we are looking from this side, and this is our vertical line, so CHO group is front side and CH3 group is below side, bottom side. So here you can see this is the carbon number 1 here, and this is carbon number 2. So 1 and 2. So in carbon number 1, you can see hydroxy group is below the plane, that means it is right side of the molecule, and hydrogen is present on front side, proton is on front side, right? So hydrogen will come here, and hydroxy group will be written on right side. Now in second case also the stereochemistry will remain same, so hydroxy group is on right side and hydrogen group is front side. Now we have to find RS nomenclature of this molecule. So first priority will be always given to oxygen attached to the carbon here 1, then the second priority will be given to this carbon, aldehydic carbon. Then this one is third. Now you have to see the movement. So this is the counterclockwise direction. But hydrogen is the least priority group which is present on horizontal line. That means it is a R configuration. R configuration. Now let's talk about the second carbon. Here again first priority group. Then the second one is here. And this is the third one. So it's going in counterclockwise direction again. But because least priority group is present on horizontal line, it will become R. So the configuration of this molecule is RR. The absolute configuration of the molecule is RR. I hope all of you are clear here. Now let's move to the next question. Here again we have to find out the longest linear chain. But before starting the writing Fischer projection, I would like to tell you here how many chiral carbons are present here. You can see here. How many chiral carbons present here? 3. In previous two examples, we have done the Fischer projection of 2 chiral carbon molecule, but here we have 3 chiral carbons. Now, what we have to do? We have to imagine the molecule in particular way. I will show here. If I will look at the molecule from this side, then this methyl group and this acidic group both are coming towards our cell. But on horizontal, on vertical line, these groups should be on below side. So, but it is moving towards our cell. That means it is on front side. So we have to rotate the whole molecule. But the other way we can write this molecule is the other way we can write this molecule is from this side. From this side. So you can imagine here this CH3 group and CO2H group is both group are going away from our cell. That means it's going below the plane. If you will imagine from this side. So this is the correct way, because without rotation we can write the molecule here. So I will write here 3 chiral centers are present. That means 3 horizontal line I am drawing here, and the upside I'm at top side I am taking acidic group. And on bottom side CH3 methyl group is present. Now look at the molecule here. Chlorine is on front side. This is the carbon number 1, 2, 3. Chlorine is on front side. So what I will do here, I will take this chlorine as right side, because we are looking in this way. So this way chlorine back side proton is present. So chlorine is on front side, that means it's on right side, and proton is on back side, that means it's on left side. So I will write here. You have to imagine in 3D for writing the Fischer projection. Then let's see the second position. You can see that in Fischer projection, this horizontal line means these are on front side of the plane. But here you can see the second carbon is going below side, that means away from our cell. So we have to rotate the stereochemistry here. We have to rotate the stereochemistry. Everything will remain same, only the second carbon stereochemistry will change here. So this is the second carbon, and I am writing here hydroxy group will go below the plane because it's on front side in this molecule, original one. After rotation it will go back side, correct? Then hydrogen and chlorine are on same side. That means we have to write here hydrogen on chlorine side and hydroxy group is on back side. Now let's talk about the third carbon. In third carbon you can see here CH2OH group is present on front side, that means on chlorine side, Cl group side. So we have to write here CH2OH, CH2OH, and here hydrogen, correct? So we can write in this way, and the other way is also there to write the molecule. If we want to take this CH2OH on bottom position, that means on at CH3 position, so we can interchange these two groups here, but then we have to interchange these two groups also after that. I will write here, then it will be easy to understand. We have to write everything same way, everything in same way. And there are three carbons, Cl, hydrogen, hydrogen, and hydroxy group. Now this CH3 and CH2OH will replace each other, and I will write here CH3, correct, and CH2OH. But this will here the stereochemistry will change, because if we will interchange these two substituent, then we have to, after interchanging these two, we have to interchange these two also. That means here CH3 will go on left side. CH3 group will go on left side here, and hydrogen will remain here. Now we have to check the stereochemistry of absolute configuration of both the molecules here. So here for first carbon, the highest priority group present on for the first carbon is halide, halogen. First priority will be given to Cl group. Then second is acidic group 2, and third priority will be given to the whole molecule. So 1, 2, 3. It's moving to counterclockwise direction, but because of least priority group present on horizontal line, we will write here R. R. Then for second carbon, for second carbon, the hydroxy group will be given first priority. Then second priority will be given to the whole group, this, and the third one is this one. So it will move in clockwise direction. Clockwise direction means it's the R configuration, but because of the least priority group present on horizontal line, it will become S, RS. Now for fourth one, the first priority will be given to the whole substituent present here, 1. Sorry. First priority will be given to this CH2OH group. Then the second priority will be given to the whole group, and the third one will be given to this methyl group. So 1, 2, 3, it will move to counterclockwise direction. That means it is S, but because of the hydrogen present on horizontal line, it will become R. So the configuration is RSR. RSR. Now let's cross check the configuration here. The first priority will be given here for Cl group, then second is acidic group, and the third one is here. So it will move in again same direction, counterclockwise direction, that means it is R. Then for second carbon, because here we have already found out that configuration, it will be S. You can cross check by yourself. Now for third one, I will write here, for first priority will be given to CH2OH group, then the second priority will be given to the whole group here, and the third one is methyl. So it will move in counterclockwise direction, but we will write here R because of least priority group is present on horizontal line. So I hope the absolute configuration and feature projection of this molecule is clear to you. You can practice yourself for solving more questions here. Now we'll move to the next question. Here you can see that again we have three chiral carbon atom and we have to write Fischer projection. So vertical line is our longest linear carbon chain. I'm writing here. Here I'm writing vertical line, then three chiral carbons. Now I'm looking at the molecule from this side, because here you can see the acidic group and methyl group both are away from ourselves, that means it is the below side of the plane. So we don't have to rotate the whole molecule, we just have to change the stereochemistry of that second carbon to make it on front side. So I will write here CO2H group, acidic group, as it is, and then CH3 group. Now you can see here Cl is on back side of the plane, below the plane, that means it is on left side, and hydrogen is present on front side. And in the second carbon we have to change the stereochemistry, because in previous case we have already discussed it's going away from our side ourselves, and horizontal line is always showing the above plane geometry, but here it's below, so we have to change the stereochemistry. So Cl group is here back front side, that means it is on back side, so it will become on left side, and hydrogen will be on front side, that means right side. Now for third carbon you can see here Cl group is on front side wedge position, that means it is on right side, and hydrogen is on below the plane. Now we have to find out the absolute configuration of the molecule here. So first the priority will be given to halogen atom 1, then second is acidic group 2, then third is given to here, correct? 1, 2, 3. It's a clockwise direction, but because of horizontal line have hydrogen group, it will change the configuration. So the configuration will become S. Then for second carbon, priority will be given the same manner. First priority will be given to the chlorine atom. Then second priority is the acidic group containing carbon atom. Then the third priority will be given to the this methyl group containing carbon atom. So it will go in clockwise direction again, but again because of the least priority group is present on horizontal line, it will become S. Now let's talk about the third carbon atom here. The third carbon atom priority will be given in same manner again. First priority is Cl group, the second priority group is this whole group, and the third priority will be given to methyl group. Now it will go counterclockwise direction, but because of the same reason hydrogen group is present on horizontal line, the configuration will be reverse here, and it will become R. So the absolute configuration for this chiral center is S, S, R, and the correct Fischer projection is written already here. So I hope all of you are clear here. 1, 2, 3, and configuration is for 1, 2, 3 carbon. Let's see the next question. This is the last example of this Fischer projection and absolute configuration. So here again we have 3 chiral centers but 2 acidic groups. So I will write here again we have to look at the molecule from same direction again, because both are going away from ourselves. So I will write here vertical line, then 3 chiral centers, then CO2H group, CO2H group. Now I am considering this carbon atom as first carbon. We have to write any any of these carbon as 1, because both have same substituent. So these 2 carbon atom have same substituent present. So I am writing in this way. This molecule has symmetry. That's why I am writing in this way. Have plane of symmetry is present in this molecule. So here bromine group is on front side above the plane. That means I have to write here on right side bromine. Right? Now the hydrogen group is present on below the plane, so it will be on left side. In second carbon, chlorine group is on back side, but we have to rotate the stereochemistry, because I have already discussed it is below the plane and horizontal line means it's above the plane. So we have to change the stereochemistry for Fischer projection. So chlorine is back side, that means it is on front side. So it is on same side as bromine is present. Both bromide is present on same side. Correct? So this is the Fischer projection of this molecule. Now we have to find out the absolute configuration of each carbon. So here the first priority will be given to the bromine present here, and second priority group is acidic group present here, and the third priority will be given to the whole group. So it will move in this direction, means counterclockwise. Then it counterclockwise means S, but it will become R. Again the same reason, hydrogen is present on horizontal line. For second carbon, the first priority group is this chloride halogen, and the second priority group is here. Here both the carbon have same priority. So this is not the chiral center. This carbon atom is not the chiral center, because here, as I told you, plane of symmetry is present. That means this group and this group are same priority group, have same molecular weight. So this carbon is not the chiral center present in this molecule. And RS configuration is possible only for chiral center. So here we cannot assign here RS nomenclature for this carbon atom. Correct? So for the third carbon atom, we will write here. First priority will be given to Br group. Then second is acidic group, and third is the whole group here present. Okay, then it will go clockwise direction. Clockwise direction means R, but because of hydrogen present on horizontal line, it will become S. So RS is the absolute configuration for the chiral center present in this molecule, and the second carbon atom is not the chiral carbon, so we don't have to write the absolute configuration for this carbon. So RS is the configuration for two chiral centers. I hope all of you are clear here, and you have to solve few examples by yourself. And if you have any difficulty doubts regarding these questions, we can discuss in next section. Now let's talk about the question number 2. So before before going to the question number 2, we have to discuss the brief introduction about the absolute configuration of the molecules. In previous question, we were finding out the absolute configuration for chiral centers, but here we are talking about the absolute configuration of whole molecule, and we have to write the whole molecule in Fischer projection. So, uh, the what is the configuration of the molecule? Here, chiral allenes are present here. For example, so chiral allenes have two different groups on terminal carbon atoms, right? Then only it will give the chirality. So chiral allenes must not contain a plane of symmetry. So if it will contain the plane of symmetry, then it will become achiral. So for chiral molecule, the condition is that the allene should always have a two different group present on each terminal carbon of the allene molecule of the molecule. So in first case, you can see here we have two different group at terminal carbon. Here also we have two different group at terminal carbon atom. That means it is a chiral molecule, and there is no plane of symmetry present here. You can pass the plane, but you will not get the stereochemistry as mentioned here. So there is no plane of symmetry. But in case of B, you can see here this carbon have same terminal group. Same group is present on terminal carbon atom. So again, it's not satisfying the first condition. Then the second condition is it has a plane of symmetry. Then second condition is also not satisfied, and the molecule is achiral. This molecule is achiral. Okay. Now let's talk about the question number 1. So here we have to determine the absolute configuration of the following molecule. So, we have to look at the molecule from one side. Again, I will tell you the same thing. We have to look at the molecule from this side. See here, I'm looking at this side. So, whenever you are looking at the molecule from one side, you have to draw that line at solid line as a solid line. So, I will write here. I will show you here. See, we have one, before solving the question, we will solve the example. So here you can see this is the allene, and in allene, which configuration is present? How we will know that? So we will look at the molecule from this side. You can see here, this side. So this is the vertical line. This is the vertical line. So I will write here vertical line here. And this is below the plane chlorine group, and CH3 group is front side. That means it is a perpendicular line, perpendicular group present to this horizontal line. So this is a horizontal line, this vertical line, sorry. So it is a perpendicular. So we have written in this way. Now OH group is on a top position, so we have written OH, and CH3 group is on at below position, so we have written CH3 group at below position. Now the second thing we have to look at here, this horizontal line has Cl group below the plane, and we are looking from this direction. That means it is on left side, and CH3 group is on front side. That means it's on front side, on right side. Okay. Now how we are giving here priority? The question arises here. How we are giving priority here? Everybody will have question here. Why we have given hydroxy group first priority, but uh, in case of the priority group, we have to give the second priority to the chlorine group, but here we are giving the second priority to the methyl group. Why? So always remember, when we are finding out the absolute configuration of the molecule, so when we are looking from the one direction, always the front side uh, group. Suppose this is OH and CH3 group is present here, and we are looking in this direction, and it's coming first, the first carbon. So first here, this is the first carbon. So we have to draw solid line on that direction. If you are looking from that direction, we have to draw solid line, and always remember that we have to start the giving the priority from that line. So in these two molecules, we have to choose the priority. So first will be given to hydroxy group, and the second priority will be given to methyl group. but because we are just talking about this carbon atom priority, this carbon atom's priority group. So here hydroxy group has first priority and methyl group has second priority. Correct? Now for horizontal line we will go later. So after giving the priority for vertical line, we will move to the horizontal line, and in horizontal line we have two groups, chlorine and CH3. So chlorine has highest priority compared to the methyl group, so it will be given third priority. Now you can see here 1, 2, 3. It's moving in clockwise direction. Correct? Clockwise direction. So the configuration will become R. So many of you will ask here why we are not giving as configuration, because least priority group is present on horizontal line. So it is only for chiral carbons. It's a rule only for chiral carbon atom. Here we are talking about the molecule. So in case of molecule, we are always giving a priority in vertical line and then horizontal line, depending on the side we are looking at the molecule. We will solve some examples, then it will be more clear to you. Now here you can see here the same molecule is here and it has different priority. Here you can see that CH3 is on different side, that's why the priority has changed here and it will become counterclockwise direction, that means anti-clockwise as molecule, as configuration. So the other possibility is that you can look at the molecule from this side. Suppose you will get the same configuration. I will write here. If you look at the molecule from this direction, what will happen? I will draw here. So because it's on horizontal line, so we have to draw, we are starting from horizontal side. We are looking at the molecule from this side, that means horizontal line is coming first, then vertical one, right? Vertical one. So at horizontal line you can see chlorine group is present at right side. If you are looking from this direction, it is on right side, then CH3 group, correct? And then on vertical line OH group and CH3 group is present, correct? Now we have to give the priority here, because we are viewing from this side, this carbon is first carbon, so we have to give the first priority to uh, the substituent present on this carbon. So the first priority will be given to this chlorine atom, then the second priority will be given on the group say present on the same carbon, that is CH3 group. Now the third priority will be given to the hydroxy group present on vertical line, and the fourth priority will be given to the this CH3 group present on vertical line. Now what is the direction? 1, 2, 3. This is the clockwise direction. Clockwise direction means R configuration. So both the configuration are correct, right? You can write any of these configuration according to your convenience. Both are correct. So you can imagine the molecule in both the way. I hope you are clear here. Now let's talk about this one also. Same. If you are looking at the molecule from this side, what will happen? Horizontal line will become solid because it's the first carbon. You are looking from this side. So the carbon is coming first here, this one. And the substituent present on this carbon will be given a first priority. And here OH, CH3, and here CH3 is on right side, correct? And here it is on left side. So sorry, Cl. This is given a first priority. This is second priority, third, and the fourth one is methyl group. So it's moving in counterclockwise direction, that is S configuration. So the correct configuration is S here. So I hope both the molecules are clear to you. Now we will do in our example. This was the just example. Now we will solve for this alene. What we will write here? Suppose I am looking at the molecule from this direction. So vertical line is our solid line. I will write here. Vertical line is our solid line, and this is the horizontal line. So CH3 group is present here. Then hydrogen. Then this CH3 is below the plane, and we are looking from this side. That means it is on left side. Left side. And hydrogen is present on right side. Now first priority will be given on horizontal vertical line. So this is the first priority group. This is the second priority, and this one is third. So it will move in which direction? Anyone? Clockwise direction. That means the configuration, absolute configuration for this molecule is R. I hope this is clear to you. Now let's move to the next example. Next question. This is only for alene molecule. Now we will discuss the other example. This is a biphenyl group, or we can say bicyclic group. This is a bicyclo group. So it's same in a similar way we have to find out the absolute configuration of the molecule. As we have discussed in alene, we have to look at the molecule from one direction again. So here I am giving example first, then we will solve the actual question here. Suppose we have biphenyl group present here, and we are looking at the molecule from this direction, this side. So this is the first vertical line, and this group is present on front side, and this is present on back side, right? And we are looking in this way. So A and B will be on vertical line. So here you can see A and B and vertical line, but it is solid line because first we are looking from this side. So the first A and B is coming first. Then after A and B we are getting A dash and B dash carbon. The A dash present on the carbon is next to behind this carbon atom. That means we have to consider the A and B on solid line, because we are from here we are reaching A and B first, then after that we are reaching to the A dash and B dash. So A and B vertical line is solid, and A dash is back side, so it will come on right side, left side, sorry, left side, and B dash is on front side, that means it is on right side. We are looking at from this direction. Always remember the direction. Okay, this direction. So now if you, this is the way you have to write, and in same in case of alene you are giving the priority to the solid line substituent. So in similar way you have to give the priority uh, to the group present on the solid line of the projection, Fischer projection. In here also you can see that we are looking at the molecule from this side, right? And the priority will be given on based on the configuration of solid line here. Priority group, different priority group present on the solid line. Now let's talk about our question. So if I'm looking from, I will solve both the possibilities here, don't worry. So if we will look from this side, suppose this side, so what will happen? Our vertical line will become solid line, correct? Now this is the horizontal line here, correct? Now NO2 group is present on top position, top side. So I will write here NO2. CH3 group is below side, and this CH3 group is below the plane. That means it is on left side, and NO2 is on front side, correct? Now first priority will be given to solid line. That means nitro group 1. Then this is the second, then third, and fourth, correct? Same as alene, we have to give the priority as we have given in alene. 1, 2, 3, right? This is the counterclockwise direction. That means S configuration. The absolute configuration for this molecule is S, correct? Okay. The second way we can imagine the molecule from this direction. So here you can write this way also, like horizontal line we are writing in solid, and this is the vertical line. So here on horizontal line, if you are looking from this side, this nitro group is on left side, right? We have to imagine in 3D, then only you can write the absolute configuration. NO2, then CH3 group, and vertical line will remain as it is. NO2, CH3 group, correct? So this is the first priority, this is the second, and third and fourth priority will be given to this methyl group. So what is the direction of the rotation? It is 1, 2, 3, that is counterclockwise. Again the S configuration is coming from this projection. So the correct absolute configuration of the molecule is S. I hope all of you are clear here. Now if you have any doubt, any difficulty regarding these questions, you can ask me in next lecture, and I hope you are able to solve the current year assignment question. If you are getting any difficulty, we can discuss in further lectures. Thank you so much for your kind attention. Thank you.